As was mentioned, I'm Valerie Brogdon, and I manage the SEMFib Lab at the Center for Advanced Materials Characterization in Oregon, or CAMCOR for short. So CAMCOR is very similar to the Canadian Center for Electron Microscopy. We've got a lot of the same types of instrumentation that they have, including SEM, FIB, TEM, XPS, many other TLAs and FLAs, which of course is three-letter acronyms and four-letter acronyms. And it's probably a very similar business model, I would imagine, where we do sample work for industrial and academic clients, and we also provide trainings and we teach classes and so on. So one of the tools that we have at CAMCOR is the Helios Hydra Plasma Fib. And we actually had the pleasure of being very early adopters of this tool. So we got to find all the problems with it. But I'm also a little ahead of the game when it comes to figuring out how to make it work. So if anybody ever has questions about TEM prep on the PFib, or slice and view, or giant cross sections, or where to whack it with a screwdriver when the ion getter pump won't turn on, or where your coolant is probably leaking from, you can feel free to reach out to me. I have definitely learned some tricks over the years. But one thing that makes our Hydra PFib unique compared to CCNs is that we have access to several different ion species. So in addition to just xenon, we can also use nitrogen, oxygen, and argon. And there are a few different things you can do with other ion species that xenon doesn't do. But if I'm being honest, like we mainly just use xenon. Xenon is a perfectly good ion to use for almost all of your applications. So good for CCM for not falling into the shiny trap of paying more to have all the different gas options when you only just use xenon. But all of that talk about our PFib was really just to set the stage for the real meat of this presentation, which is a new product that I invented with a few of my colleagues that we call Noble Dome. So what is Noble Dome? It is an inert atmospheric glove box that attaches directly to an electron microscope. And it is this bubble right here on the side of my PFib. And when I say inert atmosphere, of course, what I mean is there's no oxygen in that bubble. It's filled with a noble gas like argon that's not going to react with your sample. Now, you don't have to use argon, or you don't even have to use a noble gas. You could use nitrogen or really any gas you want. But most people seem to be interested in using argon because it's cheap and it's non-reactive. So what is Noble Dome for? Noble Dome allows you to manipulate, unpackage, and load samples into your FibSem without exposing them to atmosphere. And why wouldn't you want to expose your sample to atmosphere? Well, if you're working on battery materials, batteries tend to be made of things like lithium and sodium that are violently reactive with the atmosphere. You've probably seen some examples of batteries bursting into flames. That's why. It can also prevent surface oxidation on microelectronics, on 2D materials, on quantum materials, on nuclear materials, on powders, and more. Basically, anything that has a lot of surface area compared to how much volume it has is going to oxidize very rapidly. So if you want to get images of your sample in its pristine state, you're going to need to protect it from the atmosphere. So Noble Dome was invented, designed, prototyped, and tested all in my lab at CAMCOR. Why do we make this thing? We made this thing to enable research requests that we were getting from our clients, because we were getting a bunch of clients that were saying to us, like, hey, I want electron microscope images on this sample, but the sample can't be exposed to air. Can you figure out how to do that? And I was brainstorming with my colleagues about how to get a sample in the tool without getting any air on it. And eventually I was just like, can't we just bolt a glove box to the tool? So that's exactly what we did. And we couldn't really believe that nobody had ever done that before. So we patented it. And then I was like, I feel like other research labs might want to buy this. So I started getting involved with the tech transfer office at the university to see what it would take to make this invention into a product. And then we participated in an NSF-funded entrepreneurial training that required us to interview over 100 potential customers, including Brian from CCEM. And we found out that people do want it. So now we're taking it to market, and we are really excited to be working with CCEM as our first beta customer. So they get to give us all the feedback on what they love about it, what they don't love about it, or any ideas they have for process improvement. So please use it and let us know what you think about it for our next iteration. So here are some Noble Dome action shots, and you can see in these images that you can look down on your sample from above, which is a much easier way to work as opposed to working in a traditional glove box where you have this big window in front of you and you can't look down over what you're doing. And this ends up being a really big problem, especially when you're having to manipulate tiny TEM grids with little tiny tweezers with your big fat glove hands. So while I was interviewing potential customers, I heard a lot of stories from people trying to load a TEM rod inside of a normal glove box, and they would bonk their forehead into the glass trying to figure out where the tiny washer that they just dropped went. And I've also heard a lot of complaints that there's never any light inside of the glove box, or never enough light inside of the glove box. So Noble Dome alleviates that problem because it's a transparent dome, so the light can get in from all sides. There's enough room inside of there for any tools that you need. There's even enough room for a TEM rod, and you can have a queue of samples in there ready to go, or you can even put really large samples in there. Anything that can fit inside of your FibSim will fit inside of that dome. So the glove box is lightweight. It doesn't cause any extra vibration on the tool. It just sits there on the side of the tool, the same as any other load lock. It was actually on my tool for about 2 years, and there weren't any complaints from any of my customers about vibration in their images. And you can still load samples in and out of the front door. It doesn't inhibit you from doing that. And that's actually how I do most of my work, is in and out of the front door. I only use Noble Dome when I'm doing air-free work. So here's just a few of the cool features of Noble Dome. Here's a picture of the ball valve on the top of the dome. So this is a safety feature that provides pressure relief, and it ensures that we don't pop the gloves or the EDS window. So what happens, of course, is this ball will flutter up and down to let out excess pressure. And this valve, if you want, can be connected to house exhaust, because some of these lithium sulfur batteries smell really bad when you open them up, and none of us want our lab smelling like farts. And additionally, the venting system of the FibSim is modified such that the instrument's chamber is vented with the same gas that's used in Noble Dome. So our experiments have thus far used argon gas, but as I said before, you can hook up nitrogen or any gas you want. So this is a picture of the gas panel that our engineer Steve designed right over here. And it allows us to control the flow rate through the dome, and it also includes a pressure gauge. So you can see that you just switch this switch over to argon, when you're doing Noble Dome work, or you can go back to nitrogen when you're doing regular fib work. And you can change the flow rate as you work to preserve gas, so you're not always having to purge at the highest level. So we ended up getting this Bluetooth connected oxygen and humidity sensor, and we sent this one over to CCEM along with our Noble Dome. So you can install an app on your phone or your computer, and it will monitor the oxygen and water levels inside of the dome so that you know when it's safe to unpackage your sample. And here I included a graph so you can get an idea at which the oxygen rate drops inside of the dome. So it gets down to less than 1% after about, I don't know, maybe that's like 23 minutes. But I mean, whenever the oxygen level is safe for your particular sample, that's up to you to decide. I think that this process could probably be sped up if you add some of those like hot hands that you use when you go skiing, because how those work is they're like oxygen getters. So we haven't experimented with that yet, but we'd be interested to see if that speeds things up. Okay, so here are the results of some of our testing of Noble Dome. So we just did a really simple experiment. We took some lithium metal and we looked at it in its pristine state, And then we looked at the same sample at the same location after it sat in Noble Dome for 30 minutes. And then we vented the tool and we looked at the same sample in the same location after it sat in atmosphere for 30 minutes. And you can see there's very little change in the amount of oxygen and surface topography when it sat in Noble Dome. And there's a whole lot of change for the one that we let sit in atmosphere for 30 minutes. So that shows, of course, that Noble Dome works, and this is why you need it. So while I was interviewing potential customers about whether or not they have problems with air contamination on their samples and how they solve those problems currently, the number one solution that I heard from people is that they just take their sample out of one tool and then they run with it to the next tool. And that's fine for a lot of people. You can do that. But if you have really air sensitive samples, that's not going to work in the long term. So a lot of people mentioned that if there was a solution that had a low barrier to entry in terms of cost, that was pretty easy to use, they would jump on it. So when I look at the other products that are, when I look at the other solutions on the market that are actually products you can buy, I like to separate them into two categories. They're either sticks that you can use to poke your sample into the fib, and they come with their own antechambers. So the idea is that you load up your sample into this antechamber in a separate glove box, and then you have a load lock on the tool where you poke it in. And that includes the Leica VCT, that includes the Thermo Fisher Clean Connect, and it also includes the Corum system. And the other category is these contraptions that you trap your sample inside, and you load it in a separate glove box, and then you put this entire contraption into the FibSim. And these two on the top are the Zonexus solution and the Camerath and Weiss solution. And how they work is they open up inside of your tool by remote control. So that means there's going to be an electrical feed through. So you can't really rotate your sample, and tilting is also pretty iffy as well. The solution on the bottom is kind of cool. My friend Jeff at Stanford, he invented this, and he sells these on the internet on Amazon for like $1,000 a pop. So the lid is spring loaded, and when the pressure in the chamber gets low enough, it just pops open and rotates out of the way. So it will go into the chamber air-free, but it won't come out air-free because there isn't a way to close the lid again. And I've also heard that it takes a lot of skill to be able to navigate around in the microscope with this big piece of hardware sticking out over here, but that is another solution. So if we compare Noble Dome with other solutions on the market, we can see that other solutions, well, firstly, they assume that other users already have their own glove box, and glove boxes are pretty expensive. They can be anywhere from 10 to 100K, depending on how top of the line it is. Noble Dome doesn't require a separate glove box because Noble Dome is the glove box. We literally just married the glove box to the FibSim. So other solutions have a limit on sample size. Noble Dome has no limit on sample size. There's no compartment that the sample has to fit in, no antechamber. Anything that can fit inside of your FibSim can fit inside of Noble Dome because it's a big dome. Some of the solutions, especially the ones with cords attaching to the outside, have a limit on stage travel. Noble Dome has no limit on stage travel. The only thing that's in your tool is the sample. A lot of these solutions are pretty high tech. They're really difficult to self-service, and they could malfunction inside of your instrument, which is going to force you to have to vent the system and expose your sample to atmosphere. So Noble Dome doesn't really have much that can break. There's no robotics or electronics. If something does break, it's pretty easy to fix on your own. And lastly, Noble Dome is a lot less expensive than some of these other solutions. They are anywhere from 40K to 200K. I think the last I heard of the Leica VCT, it's like 400K. Whereas Noble Dome is fairly low cost. So let's say you want to do temp prep on air sensitive samples. For anybody who isn't familiar, I'll just run through it really quick. Fib prepared TEM samples involve using the fib and the manipulator to lift a chunk of material out from your sample, and then you weld it to a TEM grid, and then you thin it down to electron transparency with the FIB. So after the sample is really thin like this, you need to be able to get it from the fib to the TEM. However, a very thin sample is going to oxidize rapidly. So let's look at how to solve this problem with Noble Dome compared to other solutions on the market. So if we look at other solutions on the market that involve these contraptions or these stick and poke things, what you do is you load the sample into your contraption inside of a separate glove box. You move the contraption to the dual beam. You then put it back on the contraption and move it back to the glove box, and then put your grid into the sample holder, the TEM holder, I mean, and then you put the TEM holder and the TEM. Okay, with Noble Dome, you can just fit the TEM holder right here in the glove box, and then when you're done, you can move it straight over to the TEM. But to do that right, you need to make sure that the TEM lamella is not exposed to air on the way over from Noble Dome to the TEM. So that means Noble Dome needs to be used in combination with other solutions on the market. So here's an example of an air-free TEM rod that will fit inside of Noble Dome. It's by a company called Zonexus.
You put it in a
So,
glove box,
oh,
and
this
you
is a
retract
video that
this little
I'm gonna turn
bit,
down the volume. Oops. Okay,
And then this is just like a cap.
yeah, so you can see
That's
there's a little O-ring on this
That's
retractable
on
cap.
the inside of there, and
Right.
then it comes out and then you. Okay.
Yeah, that's a video that I took at M&M. So of course what happens is you put the grid inside of that little retractable part, and then it seals your grid in there. And I understand that CCEM has a rod like this made by Gatan, so that's great news. Here is another solution on the market, also from Zonexus, that I think is really clever and I think could be really useful. So it's also a retractable TEM rod, but it comes with this unscrewable fib cartridge. So you can load this whole grid holder directly into your fib and then prep the lamella on this whole thing and then screw it back into this TEM rod, retract it into the TEM rod, and then take it over to the TEM. And that's great because it solves the problem that I've heard many people complain about, where it's really difficult to manipulate tiny little TEM grids and tweezers with your big fat glove fingers inside of a glove box. So in conclusion, this presented prototype Noble Dome addresses the challenge of loading air-sensitive samples into FibSim instruments with a practical and an innovative approach. It eliminates the need for intermediary glove box or inert gas transfer shuttles, and it allows direct sample transfer onto the stage on an oxygen-free environment. So it's really simple. It's a lot cheaper than other solutions on the market. And sometimes the simplest solution is often the most elegant. So we are very excited for feedback from CCEM users. Please let us know what you think about Noble Dome and where it could be improved. It's been a really amazing learning experience taking this invention to market, and I'm just excited to see where it goes. So thanks a lot. Here's my email. Feel free to screenshot that if you ever want to reach out to me. And that is the end of my presentation.